Modern world, it's hard to imagine modern world without an electricity. And when we lose it, our life slows down. We lose a lot in comfort without ordering things like light, transport, shop, uh, internet connection as well. But the only one to win in this situation are lovers on a date and the candle sellers. But life can not only slow down but even stop when some kind of critical infrastructure suffer from outage. So my name is Vitaly Opryshko, and today, together with Dmitry Sevastyanov, Evgeny Benishin, and Mikita Drebzhinsky, we will show you our solution to prevent such situations. Main factor of blackouts and outages stems from the basic principle of energy system operation. The amount of generated electricity must correspond to consumed in every single moment of a time. So energy system, like a scale, consists of three main parts, like generation, transmission and distribution lines, and the biggest part to which we all of us belong, consumers. A little small talk. Maybe some of you participate in Earth Hour. This event is very nice, but we have to keep in mind that in case of mass demand reduction, energy system operator will put to stand by or switch off generation units. And an hour later, when the demand will rush, they have to balance it again and send command to the generators, which will bring an enormous amount of CO2 emissions. So what system operators do? So they balancing in case of shortage and in case of surplus, they use the balancing units or use import or export with bordering countries. So for Ukrainian energy system, we have some threats, and the main of it is the island mode test as a requirement for European networks integration. So the island mode test must check like our inner capacity to balance our energy system. So in island mode, all the interconnection will be cut off, and we can see an example of unprepared island mode, which was in Italy in 2003 and affected 56 million people. When the Italian system operator lost two lines with Switzerland, it takes 2.5 minutes to switch the whole country, and it takes 12 hours to bring it back to life. As a result of 10 largest accidents worldwide related to imbalance in the power systems, 1.6 billion people were affected. Texas power crisis in February 2021 brought property damage worth 20.5 billion. So just imagine that at a scale example, we have the demand side and 150 megawatts of demand of aggregated demand power is equivalent to one thermal power plant unit, and this can reduce CO2 emissions by nearly 188,000 tons per year. So what is our solution? We allows consumers who show the willingness to participate in such project to unite them in aggregator entity and provide services to transmission system operator like ancillary service or balancing market services, to distribution system operator like flexibility services, and prevent renewables limitation. And of course, for consumers, it becomes like a cost reduction, home energy management, and general positive impact. So the steps we need to take is to create the whole logic, develop the application and hardware part. Then we plan to pilot test on domestic storage water heaters, because they will not bring like disturbance to the systems because they are not very powerful. And then we can check the same logic on industrial consumers, which are very sensitive due to production processes, and then like roll out the public aggregator platform for the whole who are interested. So our concept was looking like an app to add some devices and to create a schedule when this device can be available for the aggregator. For example, if we use a water heater or a boiler example, we all know that we use it in the morning before the work and in the evening when we come home. So that the total day it could be available for direct load control. As for today, we developed an app design and machine learning algorithm to unite this device, the capacity of demand to provide the services, and the hardware part with which will look for the domestic side for the boilers will look like a smart plug with IoT controller. So what are the issues with the project? So as we see, we have unclear Ukrainian legal framework for aggregators and demand response, but experts from DTEK are already involved in working group with Ukrainian system operator and SIGRE working groups. We have a lack of information about NTSOE integration process and total absence of DCO flexibility market regulation.
As a conclusion, 40 seconds left.
As a conclusion, our solution will ensure energy security. It will support Ukrainian energy system during integration process, reduce price pressure from reserve generators, prevent renewable energy limitations. It will bring Earth hour on everyday basis and reduce consumers' electricity bills as a provided services. So we support goals number 7, 9, and 11 of SDG and these particular KPIs. So thank you for your attention.
All right, brilliant. Right on time. Right on time. Excellent. Excellent. All right. So Helen and Mary, it appears that Joseph has just dropped off, but he'll be back shortly. So we'll begin with Mary, perhaps, to give Helen a bit of a breather.
Thank you, Vitaly. I think great presentation there, and also, you identify the gaps which are there. You also identify the barriers to move to the pilot stage, which is essential and which is important. I have a question on, energy is usually a big issue in terms of, collaborations and partnerships to ensure that what you are working on actually comes to realization. So what are the coordinated efforts that you envision to kickstart so that this can be a reality? Secondly, in terms of cost implications, the hardware, the controllers that you're working on, how will that be? And lastly, how much power are you injecting into the grid? Or is this an off-grid system, or are you injecting it directly into the grid?
Okay. So if we are talking about like a partner, so the pilot project, as DTEK is the biggest Ukrainian energy company, so we own in our company portfolio we have like a DTEK grid department on which we can test like the flexibility market issues and to get the feedback from the experts on how this works and what kind of services they need and in what time. Like for example, we take a case with smart chargers and limit capacity of the building when you can't put more electricity to the building but want to charge a car, so you can probably limit some devices inside the building and your car will charge outside. Also, during our SDG Young Innovators Camp, the team from Ukrainian system operator, national power company, was participating too. So we have like the new networking. This networking bring us insight that there is a working group on aggregators. So we are participating there. I hope I answer your question.
Yeah, thank you, Vitaly. Great work.
All right, Helen, you want to go next?
Sure. Yeah, it was a really interesting presentation, and I learned something about how energy works, and about Earth Hour. I was curious to know whether it seems your focus is on the Ukraine, but if it works, is this something like how would you see it working in other parts of the world, even in like lower resource settings? In terms of being an alternative way to manage power consumption, or perhaps even maintain more stability for other countries that perhaps have weaker power systems or infrastructure. Just curious.
There is like I think it could work in every country, because they exist in like demand response programs, or like their goal is to reduce consumption in a peak hours, and like our solution looks for the services which are usually provided by generators. So I think if the power network have a smart meter, so this solution could be possible integrate for with the help of utility company who owns these smart meters. And the energy, the total, like, to sum up, the energy systems are similar in every country, with some small differences like frequency, but the general concept is the same. We have generators, and we have consumers, and we have someone who balance the power system.
All right, awesome. We have 1 minute, so I'll have Joseph speak just
Yes,
before
thank
the time
you.
passes.
I jumped off the call by accident, but I'm back. Quick question for you. Thank you for the presentation. I was curious about leveraging existing companies, well, let's just say manufacturers of, you had water heaters as an example, but anything in your home that already has connectivity to the internet, that you could just partner with those companies as a way of a low-cost way or a lower-cost way of getting to some control features that already exist.
Yes, as we were doing some kind of research, we even find that there is some legislation that these controllers for direct load control has to be pre-installed in a new boilers, probably in Japan. But I'm not actually. Probably I missed this information. But after we check our solution, so probably we'll contact these producers and show them the result, that it can reduce the costs of the equipment.
Indeed.
All right. All right. Thank you very much, Team DTEK. We hope to see you improve on your solution. Everyone's excited about what you've come up with already, so we look forward to seeing what you do with it. Thank you very much.